So good morning, everyone. Great to see everyone here this morning. So welcome to DEVOXX. I hope you all enjoyed the keynotes. I can't promise that I will be as funny as Chet, but I do hope that you come away with a couple of good ideas. I'm very happy to be in Krakow again. I was here last month for GeekCon, and I really love this town. I only have one problem: I don't understand Polish at all. So this time, instead of a hotel, I booked an apartment. So I need to go to a supermarket, and that's a bit of a problem because I have no idea what I'm buying. I can kind of guess what milk is, but yeah, but I can manage. As long as I have my breakfast and my coffee, it's fine. And after a day, I was reminded about what I love about Poland. First of all, vodka. Yeah, Poland has fantastic vodka. You all have your preference. This is mine. I have no idea how you pronounce this. Zubrowka Czarna? Is that right? Czarna. Okay, great. See, I can't speak Polish. It's just vodka. Anyway, so this is probably not even the best that you have, but I like this one. And I do have fond memories of this one. I was here for a speaker's dinner 2 years ago, and I remembered that this one was very abundant at the speaker's dinner. The rest of the evening is a bit blurry. The next one that I like about Poland is beer. I'm from Belgium, and you guys have better beer than we do. And we're known for our beers. It's really great beers, and you have more beers in the supermarket here than we do. So yeah. And the last one, Kielbasa. It's awesome. I don't need to say any more than that. So great beer, great vodka, and Kielbasa. Why aren't the Polish a global superpower? I don't know. So this is some information about me. You probably know my name because you probably read who's giving the presentation. Otherwise, hi, I'm Lieven. That's my email and my Twitter account. Some people say that I need to take myself a bit less serious, so it could be that there are some random thought of mine popping up on that account. But I do tweet about a lot of tech stuff as well. I work for Atomist. We're a group of people, and we have a mission to fix deployment, and in a broader sense, automation for development. Why? Because we believe that the current approach and the tools that exist right now aren't really suited for the problems that we have today. And we are trying to provide a solution, which I'll show you. You probably are asking why, because you do have existing systems, and they probably work for you, and you love them. But try and let me explain. So first I'll tell you what I'm going to talk about. I'm going to give you some background on why we do what we do. I'll show you a demo. And in the end, I'll open up some questions if you should have them. So the cloud-native world has become a bit challenging for an organization. On the one hand, you've got a lot of new cloud architectures and new cloud architecture styles. They all have their own unique way of working with them. So whether they're containerized or something else. And there's a lot of variation out there. Sorry. And smart people are always thinking of new ways to do deployment, automation, stuff like that. We also build a lot more services. So we used to build like those big monolith applications, and now we do microservices. Well, some aren't that micro, but hey, what's in the name? And thanks to those microservices, we also have a lot of new deployment scenarios. So you've got the PaaS solutions, platform as a service. You've got Kubernetes, Docker Swarm. Sorry if you're using that. And we deploy way more often than we used to. We used to deploy like once a week, once a month. Now there are companies that are deploying multiple times a day into production. That was nearly unthinkable a couple of years ago. So this all has changed how we behave as a team, and it has changed organizations because they need to deal with that new complexity. So top-performing teams stand out from the rest of the pack, and they all share some traits. They deliver more frequent, and they aren't afraid of delivering more frequently. Because they have mastered how to deploy their software, and they can easily roll back if something goes wrong. They also take less time to go from a feature request to something that goes into production, because deployment is just a non-event for them. It's not really a big deal. And because of the fact that they deploy it often, they don't have that much visible failures, because by the time a user detects a failure, they either detected them themselves and are deploying a fix, or it just doesn't take that long to deploy a fix after they created the code that fixes the problem. So delivery is something that they mastered. But however, not everyone is that lucky. The teams that I was talking about tend to exist in very specific ecosystems, and larger companies tend to have a bit more inertia and internal process, and that kind of counteracts that behavior. So for big organizations, the multitude of microservices and figuring out how to keep everything maintainable has become a bit of a nightmare. They see all these applications and microservices in their company, and there are new ones popping up every month. So there's YAML everywhere now in your code base, and it's controlling your development and your deployment processes. So in that case, every single project has its own unique snowflake, its own unique YAML file to control those processes. Well, I'm not saying YAML is bad. Well, I am saying YAML is bad, but YAML is evil, actually. But that's beside the point. Who can recognize himself in the following statement? Yeah, I know, right? We've all gone through this. Our new project kind of looks like one that we already have, so we can copy paste that code into the new repository, and it works after we did some small changes. So, and I said code, sorry, it's YAML. YAML is not code. And we move along like nothing happened. And we think that's fine. I thought I was fine. I confess I did this for many years. For me, it was like, okay, I'm starting a new project. I'm adding a new YAML file. It works. I'm happy. But I was blissfully unaware of the debt that I was creating. So by the time I took a step back, I was actually seeing the snowball consisting of all those unique little snowflakes that I was building coming right at me. But until that point, I thought that approach worked. And it can work for like 10 services, maybe 20. But what I want to say is, we don't really realize the problem until it's too late. But scale the approach to 100 services or 1,000 services. There are companies that have 1,000 microservices. Who here has a company that uses 1,000 microservices? Nobody. But over 100? Yeah, see, there are people that have over 100. So copy-paste no longer seems like a great idea anymore. But we're limited by the tools that we have. A lot of the tools require one YAML per repository. So hence our mission. We see that the tools no longer fit the purpose of the current problem. And the tools that we have are suddenly not equipped to handle that distributed denial of productivity. That's something that we call distributed denial of productivity because it's just a lot of YAML files. So, wow. I'm definitely not saying that everybody here is an Amazon or a Netflix, but it doesn't take that many services to see a law of diminishing effects going into effect, diminishing returns going into effect. What happens if your company suddenly wants to adopt a policy that affects the YAML files or the processes that are controlled by those YAML files? I don't know about you, but I don't really like the prospect of changing about 100 YAML files just to accommodate that new policy. Remember, those are unique snowflakes, so you might get along with writing a script, but the chance that you can change every single YAML file is slim. So A lot of the YAML files that we use are actually containing also declarative conditional structures, like if statements in disguise. And once you bump into the limitations of YAML, you'd start writing scripts, like bash scripts, and calling those from YAML. Who has bash scripts in their YAML files being called? Yeah, one. So most CI systems that use YAML file definitions actually have support for calling bash scripts. This is the reason why. So at that point, YAML becomes a golden toilet. So there are a lot of fancy additions to YAML, like declarative if statements. But in the end, it's just gold layer on what's, in fact, still a toilet. However, I don't believe that every project is a unique snowflake when it comes to deployment and automation. There are patterns to be seen. And where you have patterns, you can make a blueprint of that pattern. And blueprints are like maps. You can take a look at them, and you know where you are, what it's going to do, and what needs to be done. You've got a context. And with a blueprint, you open the door for self-reliance and self-service. So to achieve this, we have 4 things that we need to do. We need to integrate with all the systems that we use as a developer. So you've got your source control system, you've got your issue management system, and everything can emit an event. So your source control system can emit a push event, your issue management can issue an event when you do something with an issue. Your deployment environments can raise events when something goes wrong, when something's crashing. Everything can emit an event. And you need something to correlate those events. So, for example, if you do commit, it would be nice if you can link that commit to an issue on your issue tracking system. If something goes wrong into production, it would be nice if we could track that back to the commits that actually are in that release and notify the developers. I'm not talking about the blame game, like you broke production. No, it's just about notification, like something went wrong, you might want to take a look, and at least you got the right persons to talk to. And we want that to be completely automated. Well, at least as much as possible. I'm lazy. I don't like to do many things at the same time, every time. So I just automate out everything, or at least I try to. And we want to make sure that it's policy-driven. So the blueprints and the patterns that we see, we want to translate that into a policy that we can distribute throughout our organization, or at least our own team. But we can already do this, you say. Yeah, you're right, but it takes a lot of YAML and a lot of scripts in order to achieve this. And I don't know about you, but I don't like writing one-off bash scripts just to get something working. Wouldn't it be great if we do that in code? We're developers after all. Code is our thing, and bash scripts are not code. So yeah, enter Atomist. That's who I'm working for. Our concept of self-delivery is coded in what we call a software delivery machine. That's a piece of code. That's TypeScript code. I normally get a sigh when I say TypeScript code, like, oh, TypeScript, or a laugh. And that's running in your own environments. That's running in your own company. And that contains all the policies, all the patterns, all the blueprints of your team, of your organization. So, yeah, it's a bit small, but bear with me. I'll explain. So at the top, you've got a way to interact with Atomist. I prefer Slack, but we also support MS Teams if you're using it, and we do have a web UI. And those ways, those tools communicate with our software delivery machine that is running something that's running inside of your own environment. At the bottom, you've got all the different tools that you're using inside of your organization. You've got your source control system, your issue management system, your existing CI/CD systems. Yeah, we do play nice with the other boys on the block. Your deployment environments like Kubernetes or OpenShift, Cloud Foundry, and systems that actually look at your deployments in order to find out when something is wrong, like Sentry. They send events to our backend, and just the events, not code. And it correlates those events into a model. So we've got, so we've got integration and we got correlation. And it all happens automatically. So we got automation. Great. So the software delivery machine will code those patterns and those policies into a whole. And that makes, for example, that a push event will result in a build or a deploy or something completely else. Your policy decides inside of your company. So since it's code, we can test this. We can write unit tests for our delivery. So it's no longer like pushing a YAML and hoping that it works. It's really, you can do test-driven development on your delivery. And since it's policy-driven, it's reusable by nature. A Node project or a Maven project is a Maven project. If you have 20 ways to build a Maven project, I'd say you have some different problems in your company regarding divergence. But because it's testable, and it's because it's based on the inherent policies of your company, and it's written in a real programming language, TypeScript, it's way more clear for us developers to understand and read what that thing actually does, instead of going through YAML files and trying to understand the meaning of the structure and going to tens of lines of bash scripts. Who actually likes bash scripts here? Still, a couple of people. Nobody's perfect. For those who know a bit about domain-driven design, who knows about domain-driven design? Okay, a couple of people. There's something inside of that that's called ubiquitous language. And at Atomist, we're trying to define a language for that, for delivery and for automation, and we try to create a rich data model that adheres to that language. So for example, a project, a push, a build, a goal. Those are real concepts inside of our code base that are based on the ubiquitous language of deployment. And they become a sort of an API for deployments and all sorts of automation in general. And we're using GraphQL to enable you to query that model. GraphQL rocks. So let me show you what Atomist can do. And I'm going to try and do this like. Can you hear me? Okay, great. Let me do mirror displays off. There we go. Yay. So there we go. Okay. So I'm going to go to our samples directory, our samples repository. We have a lot of samples with Atomist, and that's the ones I'm going to show you. So I'm going to start up Atomist. The flags are just for making sure that it is a bit faster. Otherwise, there's an npm install and then a TypeScript compile. But I already did that, so I don't have to do that. And it started up. So I have to choose one of my samples. So let's start off like taking the one that builds Maven projects. I'm going to show you how it works, and then I'm going to show you how it does it. So it's running. Let's take Slack. There we go. And let's do add Atomists. Create Maven project. Need to have a repository owner. Those are all the organizations that I have linked to my account. And let's do Devoxx Poland 01. It's going to ask me for a group identifier for my Maven project. Let's do a common example. And it's going to ask me for a root package. So let's say org.devox. It's going to give me a presentation of all the parameters, and I'm going to say submit. One of the things that Atomist can do is, for example, generate new projects. That's what I'm doing right now. And we're not doing that based on templates, but based on real seed projects. So it's based, as you can see, there's a seed project here. And that's a real application. That thing runs. And I'm using that application as a seed for my new project, and I'm transforming it. So we can actually do code transforms on existing projects. So it's going to ask me like, hey, I found something new. Do you want to show it? There we go. Yeah, it was a bit too slow. No, it did. So it detected the commit, and it actually said like, okay, I know how to build this. I'll build it. So this is a really simple example, so I'll show you what it does. But we also, in this machine, we have a bit of a logic. So say that I change a README file. Do you want your build to kick off when I change a README file? So let's change something. Here we go. And it's not going to do anything. Because a README file is not really a significant change in my repository, and I don't really need to change I don't really need to do the entire build lifecycle just because I change a README file. So what does this look like in code? So this is the main thing that you need to understand. So we first have a sort of an exit point, like if this happens, don't even bother. In this case, if it's not a material change, and that means changes to certain files, like in this case, if it's a change on a Java file, an XML file, or a properties file, we want to do something. If it doesn't have a POM, it's not even a Maven project, I don't know how to do this. So I'm not setting any goals. Otherwise, I'm going to do a build goal. What is that build goal? It's just a Maven build, and we do have a built-in support for Maven, so that's a Maven builder. And I'm going to do an MVN version before that. But that's optional in this case, because I don't have my version goal planned at the moment. So this is actually a very simple example on behavior for building Maven projects. But let's do a more complicated one. So let's kill this one. And let's do something with Node.js. Once again, I'm going to say, like, I can go directly into the Atomist channel, and I don't need to do add Atomist. So I'm going to say create TypeScript project. Oh yeah, the generator. Perhaps I can show you a generator. So the thing that I just showed, like create Maven project, that's the intent. That's something that you can say inside of your tool. And it's going to start from a starting point, in this case, a GitHub repo. It's going to update the README title. So if I go into the project, this one is not the same like that was in the seed project. It actually changed the README file. What it also did was it transformed the code to move all the packages. Like I said, I wanted to have it in org.devox. It's now in org.devox. So if I look at the seed itself, it has a different README file, and the structure is completely different. So it actually can do refactors of existing projects. So this one is in that com.atomist.spring. So I've got my tool started. Let's go create TypeScript projects. Once again, I need to choose a repository. If you only have one repository, it's not going to ask you that. So let's go Devoxx Poland 02. In this case, I only need to have an application name, Devoxx Poland 02. It's not going to ask me a package or something like that because it's TypeScript, doesn't know really what packages are like Java does. And I'm going to submit that. In this case, I'm going from the Express.ts example. That's something I built myself, just stupid application that does hello world on a root package. And let's go into this. So it's going to calculate a project version based on what's in the package JSON. It's going to append a timestamp so that it's a really unique version. And it's going to build the project. Shouldn't take that long because it's not really a big project. And it's also going to tag it for you in your source repository that you always have something to fall back on. So it actually now built my project, big deal. But I can also say like, add Atomists, create Docker file. My machine is actually capable of creating Docker files for this project. It's going to do transform, it's going to add a file. And in this case, it's going to do that on a branch, and it's going to automatically create a pull request to merge that branch into master. And with Atomists, we have support for pull requests, and to show those in the tools that we provide, like Slack. So you can actually request a review. You can do an auto merge in case everybody approves. It auto merges automatically, or an auto rebase based on the merging policy. You can do a comment on the pull request, or you can just do like, I want to merge this one, I want to squash it and merge it, or I want to rebase and merge it. So in this case, I'll just merge it. I'll do a squash, then I only get one commit. Otherwise, I'll get two commits, the merge one and the one that I made. So it actually did that commit into master, and because it sees like, hey, there's a Docker file, I can do something with this. It's going to do the build again. Every goal starts from a clean code base, so every goal does a checkout. The reason for that is we also support running Atomist on Kubernetes, and then every goal becomes a job in Kubernetes. So we do support caching, of course, so we can actually cache the output of one goal and use it in another goal. So it did Docker builds. And now it's going to do a Docker run locally on my own machine. So there we go. It started. And it's going to be in HTTP. And hey, hello. So it's running locally on my own machine. In this case, on my Minikube, because I don't have Docker installed. So I'm actually piggybacking on Docker inside of my Minikube. And I can also stop this container. So I actually didn't touch my console to do deployment at all. I didn't even have to go into the browser. So it now stopped the deployment, so if I refresh this, it won't work because the container is gone. But now your company changes a policy. It says like, nobody does this, nobody does Docker run. Let's do something cool with this. Who knows Rio? Nobody. That's like a tool that the guys from Rancher, really cool guys that do some Kubernetes stuff. They actually built a tool, Rio, that installs a lot of stuff like Istio in your Kubernetes cluster and makes it really easy to deploy a Docker container onto Kubernetes. I have a Kubernetes running on my own machine, on a Minikube, and I have a machine that's able to deploy TypeScript applications or Node.js applications to Rio. Actually, it can be reused to deploy any Docker container onto Rio, but in this case, I just did Node.js. because I already have a Node.js project that I can change. So let's go into the browser. Let's go into the project, Devoxx Poland 02. Thank you very much. There we go. And let's change something in the package JSON. So now it's not going to do Docker run, but it's going to do a reudeploy. In this case, it's going to deploy on a local minikube, but that's because my Kubernetes context is set to deploy to my minikube. You can just as well do this on a GKE or an Amazon or an Azure Kubernetes instance, or something that's completely on-premise. The code is running on-premise in your own company. So even if your Kubernetes cluster is not accessible by the internet, the software delivery machine will be able to access it, given the fact that it's in the same network as your Kubernetes cluster. So it's going to do a reudeploy. There we go. And give me HTTP. Rio also does HTTPS by default. So it actually deployed it on Rio. And if you go into, let's open up console, Rio PS, you can actually see it deployed that application. And if I go to kubectl get pods, you can actually see that it's running on my own Kubernetes, and actually didn't have to write one Kubernetes descriptor. We also have support for our own deployment system to Kubernetes, and you also don't need to write deployment descriptors. It can actually infer those from the Docker file, from the kind of project that you have. But Rio was a bit easier to show you, so I wanted to show you. So what does this look like? Let's go into the code. I'll show the Rio example. So in this case, once again, I've got an exit point. If it doesn't have a package JSON, if it doesn't have a tsconfig, this machine doesn't know how to handle this, so it just says like, I'm not doing anything. It's going to do a version goal and a build goal. The version goal is very important because if you don't do this, and you build a Docker file, if you do this on a branch, normally you don't change your package JSON. It's going to override your Docker image every single time because it's always 0, 1, 0. And you kind of lose your previous ones. So that's why we're doing a version goal to uniquely version your artifacts just for that build. Then we're going to do a Docker file, and we're only going to do that if it's on a default branch, which is something that you configure in GitHub. In this case, if it's on the master branch, it's going to do a Docker file, going to do a Docker build, and of course, if it has a Docker file. And the next thing is, if it's on a default branch and a Docker file, I do a reudeploy. I could just as well have done this, and this would have worked as well. So basically, if you go to the goals, the version goal is just a built-in goal that we have for versioning. We have a node project version. We also have one for Maven. We have one for Gradle. With Gradle, there's a bit of a caveat. You do need to adhere to some kind of a standard because Gradle is very flexible in how you can define versions, packages, names. So there's like 100 ways to do that. We once again have a build goal. In this case, it's using a node builder, which does a npm run compile. And it does it has a project listener, which will trigger before it does the build. In this case, it will do an npm install. Once again, it's starting from a clean code base. So normally you don't commit your node. Who commits node modules in their repository if they do TypeScript? Oh, thank you. Then I'm going to do a Docker build. In this case, going to try and find a Docker file. It's not going to do a push because in this case, I've actually tricked it into deploying onto the Docker registry in my Kubernetes by piggybacking on that Docker daemon. And it's going to create an image based on the repository owner. In this case, I can show you this, actually. Docker images. Oh. So here is the repository owner, like Devoxx Poland, 19, and then the name of the repository. And the tags is always latest, is the one that's been built latest, and the unique tag of the build. And it's going to do reo deploy. This is a custom goal, so once again, I'm going to find out what my image is called. I'm going to do some command line calls like reo run. I'm going to do reo ps in order to find out what the endpoint is. And I'm going to show that endpoint in my tool. And I'm also going to provide a way to stop that service. And that service is just going to do a reo rm, which actually removes that service. Once again, we've got a TypeScript generator. And here is the transfer that I used to create a new Docker file. So this is static, but you can do a lot of parameterization here because it's code. And it just adds a Docker file, and it's going to make a pull request. So it is all something that you can do in code, and you can test this. So let's go back to the presentation. So that was the demo. Here we go. So if you like code and if you like patterns, Atomist is actually a great option. Well, I think it is, but I'm a bit biased. If you're willing to codify your policies for everyone to reuse, Atomist is a pretty good spot to be in, actually. It enables you, as a developer, to take control of one of the most important processes in your development lifecycle, like deployment, building. So that's a very important aspect of your job, to make sure that everything gets built and deployed. So what can you do with Atomist? Well, I showed you, you can build your software. You can use the standard CI/CD stuff that you already know and you probably already do using the existing tooling. You can do CI and CD with Atomist. You don't have to. You can reuse, for example, if you've got Jenkins configured, you can use the Jenkins jobs and configure Atomist to play nice with Jenkins or just trigger Jenkins. So you can also inspect code. So like I said, we only send events, we don't send code, but the software delivery machine can access your code. And code inspections can be used to check for things that you already know, like you can use tools like PMD, find bugs, and notify people through Slack or MS Teams that something went wrong, that something is not really right in the code. So since we have an integration with Slack and MS Teams, you can also do chat ops. If you've got automated blinds in your company and they have a REST API, you can probably use Atomist to raise and lower the blinds for you using Slack. It's not really that good of an idea, but hey, you can do it. But you can also do just about anything that if you can call an API to do something for development or automation in your own company or in your own process or in your own team, you can use Atomist for that. You can also promote like standards and best practices, like I said, with code inspections. But we can also go even further. We can change your code and auto-fix your code if something is not right and we know how to fix it. So for example, we've got an auto-fix running in our own repositories that automatically manages our license files. So if you don't have a license file in your project, it will automatically add that license file on the next commit, and you never need to worry about that. We can also manage our readmes, our documentation, things like that. But we can also analyze your code in your organization and provide some pretty interesting insights. So this is something a tool that we're working on. It's a pretty old image, so I think it's already been changed. And this is a visualization of all the Docker-based images that we're using in all our projects at Atomist. So the inner one is the analysis target, in this case, Docker images. The second inner one is the organization that we have. And the other one are all the different projects that we have. In between that, we have all the base images that we're using. So we've got like Ubuntu 7.10, Ubuntu 18.04, Node 8 Slim, Node 9, Node 8. So as you can see, we're not really adhering to a policy of standardized images here. But that's pretty normal. We do have a lot of POCs. But we can take action on this one. Like, okay, I see that we're not really using the same node images. Perhaps we need to take a look at that so that everybody is on the same page. This is another one that we have. This one checks whether we've got a code of conduct file in our repositories. Code of conduct is very important for open source projects. The entire software delivery machine code, so everything TypeScript related, is open source. You can play around with that as much as you want. And here we can actually see that there are a couple of projects that don't have a code of conduct. I think we already fixed this, so this is too old. But you can actually say like, hey, this is not right. We need to fix this. But at least you're aware of the fact that this is wrong in your organization. It becomes visible. There's a lot of information that you can be gathered when you look at the code in your organization. And once you visualize it, it's really easy to act on that information. But you need a way to organize that information, to retrieve that information, and to visualize that information. That's something that we are working really hard on right now in order to provide that possibilities for developers and for companies and organizations. So if you want to get started with Atomist, you can visit our website, and if you've got a GitHub account, it's really easy. You can create an Atomist account. You can link your GitHub account to Atomist, or just use like SSO. And then you can link a Slack workspace, and then you get like the same setup like I do. I just set the setup yesterday. So, and after that, you can just build your own software delivery machine based on the samples directory that I had, or you can read the documentation where we have a quick start for developers. So what's coming next, what the future holds, is completely up to you. We welcome feature requests. If you have like a question like, hey, I want to know how I can automate this in my company. We're also doing this manually, or we have some scripts. It would be nice if we could see how Atomist does this. You just go into the samples repository and you raise an issue. We'd be more than happy to provide a sample. Or if you're really brave, you can create your own software delivery machine and raise a PR. It's even better for us. But we're always happy to answer any and all questions that you might have. And even if you don't like Atomist, and you go like, I really don't like this product, I hope that you're convinced that writing YAML isn't really the right way to go, and you really want to start writing real code. And if you're convinced, there's something called the Software Defined Delivery Manifesto. Read it, and if you agreed with it, sign it. And mind you, we're not the only ones that are doing this. There are other ones that are doing the same thing. For example, for infrastructure, for example, Pulumi is doing the same thing like Terraform is doing, but then in code, also TypeScript code. So they're actually doing things in code where YAML was also very dominant. So I welcome your feedback. Feel free to send me a message on Twitter, or to myself, or to Atomist. We also have a chat system on our website, so if you put a question in there, we try to respond as quickly as possible. Normally, I respond quicker on my Twitter accounts. So thanks very much. If you have any questions, I'm more than happy to answer them for you. You know what? Oh, what? Yeah, okay.
Okay, so as far as I understood, for instance, for Kubernetes deployments, you guys generate these YAML files like for Kubernetes itself. Is that correct?
That's correct.
Okay,
So wait, I'll respond. Did anyone? So the question was, do we generate the Kubernetes?
that was the part.
Oh, okay, that was part.
So if
Yeah.
yes, then I have another question. So basically, if we're using beta features of Kubernetes and we're using this like pretty actively, that would mean that if we, for instance, accommodate your tool, that means that we will need to wait until you guys implement these features like Kubernetes released into your software delivery machine. Is that correct?
How do you use those features right now? Do you call just the APIs directly? You don't use kubectl then?
We do have like a separate repo with Kubernetes configs for all our services. We have like a separate build pipeline for this repo and stuff. And basically we use this, like we put the stuff in the config, basically this YAML because Kubernetes uses
Yeah.
YAML. Like there is no other way. And
You can use JSON as well, by the way.
I mean,
Yeah.
okay. It would be the same, more or less.
Yeah.
So anyway, my point is that we would put like some features into these YAML files to use, I don't know, for instance, like if they deliver good load balancing mechanism which we want to use, or some metrics, or some other stuff, we would use this in YAML directly. And as far as I understood, you guys will have to implement generating this part of YAML.
Well, we provide a out-of-the-box solution, but everything is customizable by you. So if you say like, okay, our YAML files are a bit different, our descriptors are a bit different, our resource definitions are a bit different, you can override those, you can customize those yourself. So we do have hook points in order to change the resource definitions that are generated. So if you got really specific things, you can do that if you want to. It's code, you can just, we provide the hooks for that.
And for the build system, you said you have support for Maven and Gradle. So what about like more bizarre stuff like Bazel?
Not at the moment. But once again,
If we want to use it, we are going to have to implement this by our role. Is that correct?
you can do that or you can raise an issue. If you raise an issue, we'll look at it and we'll put it on the roadmap. That's the reason why I'm telling you, like, just tell us what you want, because hey, we can start going like, okay, let's support every single build system out there, but if only 2 people are using it, that's not really a waste of our time. But really, if people want it, we're going to build it for you. That's our approach. And we really incentivize people to do that themselves. So what's good? Okay. Yeah. Yeah, absolutely. Well, Gradle, you took the worst example, because Gradle files are really a pain to edit and to parse, because the most of the time how we do it, because, well, there are 2 steps. If you want to really use Gradle, I first suggest that you try to agree on a same way of working in your Gradle files, that nobody's using like the settings.gradle or the init.gradle to move some stuff around. But you can just do text replacements if you want to. You can find certain structures in your code, because we can access the content of a Gradle file. So you can actually just start changing something with text replacements if you wanted to. No more questions? Okay, thank you everyone, and enjoy the rest of the conference.